Learning objectives. In this chapter, the users would learn the following aspects of Introduction to Prevent and Breakdown Maintenance. Types of maintenance, preventive and breakdown maintenance, backup and recovery in Windows, need for recovery, techniques, log-based recovery, checkpoint, deferred and immediate updates, shadowing, catastrophic and non-catastrophic failures, recovery in multi-database environments. Introduction. Computers are the most commonly used modern invention of the 21st century. We can find computers in every household and every office across the world. Computers essentially make our lives easier. However, simplification of life often comes with some complications. It is important to realize that computers are very complex electronic machines that work with different technologies and are difficult to manage as they often break down while they are in operation. To keep these systems up and running, some maintenance has to be done. Maintenance is not about fixing things that break. Maintenance is about preserving, protecting, safeguarding, and looking after the very machines that make business possible. Maintenance. Maintenance can be preventive maintenance, breakdown maintenance. Preventive maintenance. Preventive maintenance is daily maintenance like cleaning, inspection, oiling, and retightening. It is designed such as to retain the healthy condition of the equipment and prevent failure through the prevention of deterioration, periodic inspection of equipment condition, and diagnosis to measure deterioration. Preventive maintenance is further divided into periodic maintenance, predictive maintenance. Breakdown maintenance. Breakdown maintenance refers to the fact that people wait until equipment fails and then they repair it. Such maintenance works when the equipment failure does not significantly affect the operation, production, or generate any significant loss other than the repair cost. Breakdown versus preventive maintenance. Breakdown maintenance is when a person or organization conducts maintenance of equipment when the equipment breaks down. On the other hand, preventive and predictive maintenance is when an organization conducts maintenance activities that include inspections to help ensure equipment is functioning within their expected parameters and to catch indications of minor issues so that they can be addressed before a bigger problem occurs. Computer system and preventive maintenance. Preventive maintenance is a very critical aspect of any successful IT operation, and its importance is always stressed. No matter what efforts are taken, computers still malfunction, laptops break down, servers go offline, and networks are unavailable at times you least expect. All of these problems can be reduced and kept to a very minimum by keeping up with regularly scheduled preventive maintenance, such as backup of critical data, critical software updates, and hardware components cleaning. In order to keep computer hardware in good working order, specifically its internal components, you have to deal with dust, which is one of the main sources of computer hardware failures. It is imperative to clean and properly lubricate all moving components such as fans, power supplies, the main board, and the CPU. You have to ensure that you have the right equipment, especially when it comes to cleaning laser printers. Use of regular vacuum not only damages the printer, but it might damage the image as well. Another important aspect of hardware upkeeping is making sure that moisture and heat are not near the computer hardware, especially the CPU processor and hard drives, as it dramatically affects their longevity. Backup and recovery. In information technology, a backup or the process of backing up refers to the copying and archiving of computer data so it may be used to restore the original data after a data loss event. Backups have two distinct purposes. The primary purpose is to recover data after it's lost due to data deletion or corruption. Data loss can be a common experience of computer users. A survey found that 66% of respondents had lost files on their home PC. The secondary purpose of backups is to recover data from an earlier time according to a user-defined data retention policy. It is typically configured within a backup application for the time span the data is required. In computing, the phrase backup means to copy files to a second medium, which can be a disk or tape, as a precaution in case the first medium fails. One of the cardinal rules in using computers is to back up your files regularly. Even the most reliable computers are apt to break down eventually. Many professionals recommend that you make 2 or even 3 backups of all your files. To be especially safe, you should keep one backup in a different location from the others. You can back up files using operating system commands, or you can buy a special purpose backup utility. Backup programs often compress the data so that backups require fewer disks. Most businesses employ a complete backup solution that provides storage on removable media, data compression, automatic backups to off-site storage, and automated scheduling to increase the reliability of the backups. Backup and recovery in Windows. The backup utility in Windows XP and Windows Vista helps you protect your data if your hard disk stops working or your files are accidentally erased. With backup, you can create a copy of all the data on your hard disk and then archive it on another storage device, such as a hard disk or tape, in case the original data on your hard disk is accidentally erased, overwritten, or becomes inaccessible because of a hard disk malfunction. Recovery techniques. The recovery techniques are categorized mainly into two types, namely log-based recovery techniques, shadow paging. The log-based recovery techniques maintain transaction logs to keep track of all update operations of the transactions. On the other hand, the shadow paging technique does not require the use of a log, as both the after image and before image of the data item to be modified are maintained on the disk. This section discusses the recovery techniques for the situations where transactions execute serially, one after another, and only one transaction is active at a time. Log-based recovery. Log is a sequence of records that maintains the records of actions performed by a transaction. It is important that the logs are written prior to actual modification and stored on a stable storage media that is fail-safe. The most widely used structure for recording database is the log. The log is a sequence of log records. It records all the update activities in the database. In short, transaction log is a journal which contains history of all transactions performed. The log contains start of transaction performed, transaction ID, record ID, type of operation including insert, delete, update, old value, new value, and end of transaction that is committed or aborted. Checkpoint. From time to time, randomly or under some criteria, the database flushes its buffer to database disk to minimize the task of recovery. The following steps define a checkpoint operation. Suspend execution of transactions temporarily, force write modified buffer data to disk, write a checkpoint record to the log, save the log to disk, resume a normal transaction execution. Deferred and immediate updates. Deferred update. All modified data items in the cache is written either after a transaction ends its execution or after a fixed number of transactions have completed their execution. Immediate update. As soon as a data item is modified in a cache, the disk copy is updated. Deferred update. No undo, redo. The data update goes as follows. A set of transactions records their updates in the log. At commit point under WAL, write-ahead logging scheme, these updates are saved on database disk. After reboot from a failure, the log is used to redo all the transactions affected by this failure. No undo is required because no AFIM after image is flushed to the disk before a transaction commits. Deferred update in a single user system. There is no concurrent data sharing in a single user system. The data update goes as follows. A set of transactions records the updates in the log. At commit point under WAL scheme, these updates are saved on database disk. After reboot from a failure, the log is used to redo all the transactions affected by this failure. No undo is required because no AFIM is flushed to the disk before a transaction commits. Deferred update with multi-users. This environment requires some concurrency control mechanism to guarantee isolation property of transactions. In system recovery transactions which were recorded in the log, after the last checkpoint were redone, the recovery manager may scan some of the transactions recorded before the checkpoint to get the AFIMs. Immediate update. Undo, no redo algorithm. In this algorithm, AFIMs of a transaction are flushed to the database disk under WAL before it commits. For this reason, the recovery manager undoes all transactions during recovery. No transaction is redone. It is possible that a transaction might have completed execution and ready to commit, but this transaction is also undone. Undo, redo algorithm, single user environment. Recovery schemes of this category apply undo and also redo for recovery. In a single user environment, no concurrency control is required, but a log is maintained under WAL. Note that at any time there will be one transaction in the system, and it will be either in the commit table or in the active table. The recovery manager performs undo of a transaction if it is in the active table, redo of a transaction if it is in the commit table. Undo, redo algorithm, multi-user environment. Recovery schemes of this category applies undo and also redo to recover the database from failure. In concurrent execution environment, a concurrency control is required and log is maintained under WAL. Commit table records transactions to be committed, and active table records active transactions. To minimize the work of the recovery manager, checkpointing is used. The recovery performs undo of a transaction if it is in the active table, redo of a transaction if it is in the commit table. Shadowing. In computer science, shadow paging is a technique for providing atomicity, durability. A page in this context refers to a unit of physical storage, probably on a hard disk, typically of the order of 2 to the power of 10 or 2 to the power of 16 bytes. It is convenient to maintain logs of all transactions for the purposes of recovery. An alternative is to use a system of shadow paging. This is where the database is divided into pages that may be stored in any order on the disk. In order to identify the location of any given page, you use something called a page table. Catastrophic failure. A catastrophic failure is a sudden and total failure from which recovery is impossible. Catastrophic failure often leads to cascading systems failure. The affected system not only experiences destruction beyond any reasonable possibility of repair. The term catastrophic failure is occasionally used in computer software to indicate unexpected error from which the system cannot meaningfully recover. Causes of catastrophic failure. Catastrophic failure is a complete, sudden, and often unexpected breakdown in a machine, electronic system, computer, or network. Such a breakdown may occur as a result of a hardware event such as disk drive crash, memory chip failure, or surge on the power line. Catastrophic failure can also be caused by software conflicts or malware. Sometimes a single component in a critical location fails, resulting in downtime for the entire system. Well-engineered computers and networks are designed so that localized faults rarely precipitate catastrophic failures. Recovery from catastrophic failures. To avoid losing all the transactions that have been executed since the last backup, it is customary to backup the system log at more frequent intervals than full database backup. This is done by periodically copying it to a magnetic tape. The system log is usually substantially smaller than the database itself and can be backed up more frequently. Thus, users do not lose all transactions they have performed since the last database backup. All committed transactions recorded on the portion of the system log that has been backed up can have their effect on the database redone. A new log is started after each database backup. Hence, to recover from disk failure, the database is first recreated on disk from its latest backup copy on tape. Following that, the effects of all the committed transactions whose operations have been recorded in the backup copies of the system log are reconstructed. Recovery in multi-database environment. In every computer system, there is a possibility of failure or malfunction, which may result in loss of information. Therefore, if a failure occurs, then it is the responsibility of Database Management System, DBMS, to recover the database quickly and with as little damaging impact on users as possible. The main aim of recovery is to restore the database to the most recent, consistent state. The Recovery Manager component of DBMS is responsible for performing the recovery operations. Database backup. The Recovery Manager of a DBMS must also be equipped to handle catastrophic failures, such as disk crashes, several times. The main technique used to handle such crashes is that of database backup. The whole database and the log are periodically copied onto a storage medium, such as magnetic tapes. In case of a catastrophic system failure, the latest backup copy can be reloaded from the tape to the disk and the system can be restarted. Database modifications. Database can be modified using two approaches. Deferred database modification. All logs are written onto the stable storage and database is updated when transaction commits. Immediate database modification. Each log follows an actual database modification. It means that the database is modified immediately after every operation. Conclusion. In this chapter, the users have covered the following aspects of introduction to preventive and breakdown maintenance. Types of maintenance, preventive and breakdown maintenance, backup and recovery in Windows, need for recovery, techniques, log-based recovery, checkpoint, deferred and immediate updates, shadowing, catastrophic and non-catastrophic failures, recovery in multi-database environments.